Hi everyone. My name is Pritha and I'm a developer with the Ceph RGW team at IBM. Today I'll be giving a talk on STS in Ceph RGW. These are the topics that I plan to cover for today, starting off with a brief introduction to STS. And then I'll talk about the basic building blocks of STS, roles and policies. And then I'll move on to the APIs that have been supported. After that, I'll talk about custom credentials provider and an authorization strategy known as ABAC in STS. And in the end, I'll discuss a bit about what has been implemented in STS for multi-site. So what is STS? It is a set of APIs that return privileges, that return credentials that are temporary and limited privilege in nature, and it is based on AWS STS. So why is STS needed? It provides cross-account access, and it also aids in the integration of external applications which have a large number of users, and they do not want to own permanent S3 credentials. So they can use STS to get temporary credentials and access S3 resources in RGW. So what is currently supported in STS for RGW? All the APIs return temporary credentials. RGW supports a subset of STS APIs, namely assume role with web identity, and get session token. It also implements a subset of AWS IAM APIs for performing CRUD operations on roles, policies, and OpenID Connect provider. And it also provides signature validation both for V2 as well as V4 authentication of these temporary credentials. Currently, STS, IAM, and S3 APIs all coexist in the same namespace. They use the same endpoint for talking to RGW. So what are temporary credentials? In addition to the access key ID and the secret access key, the temporary credentials also consist of something known as a session token. Session token is encrypted, hence it is opaque to the end user, but it has useful authentication and authorization information in it. It contains the access key ID and the secret access key, and the permissions that are attached to the roles, which are useful in authorizing or denying any S3 operation. The next few slides, I'll talk about the basic building blocks of STS, starting off with what is a role. A role is an entity or an identity which is similar to a user, but it doesn't have any permanent S3 credentials attached to it. It can be assumed by multiple users to get back temporary credentials, and it is associated with two IAM policies. First is the trust policy, which describes who is allowed to assume a role. So it's usually the principal element of an IAM policy which decides who will be allowed to assume a role. But sometimes the condition element of the policy also works in conjunction with the principal element for deciding who will be allowed to assume this role. So in the example shown here, the condition element is set to an external user named Bob, and the principal element is set to the ARN of an OpenID Connect compliant provider. So the user Bob belonging to that IDP will be allowed to assume this role. And in case of assume role with web identity, we currently provide support for all claims in the incoming web token to be used in the condition element of the policy. Next is the permission policy, which describes what a role can or cannot do. So in the example here, all S3 actions are allowed on a resource called myBucket and its contents. So a role can only provide access to resources inside a tenant in which it has been created. And currently we provide support only for inline permission policies, which are embedded along with the role. We do not have support for managed permission policies. And apart from the REST APIs that provide the CRUD operations, we also provide support for Rados Gateway admin commands for CRUD operations on roles. So now I'll discuss a bit about the STS APIs that are supported in RGW. The first one being assume role. Assume role mainly provides cross-account or cross-tenant access to users. So let's say there's a user A in tenant T1 and there's a user B in tenant T2, and user B owns certain buckets that user A wants to access. So that can be done by creating a role R in tenant T2, which allows user A to assume that role and also allows access to user B's bucket. So user A can now assume that role R using its permanent credentials, and it can get back temporary credentials, and using those credentials it can start accessing the buckets owned by user B. So an alternative mechanism for cross-account access can be bucket policies, but the difference between assume role and bucket policies is that in case of bucket policies, we need to go and attach a policy to each and every bucket if the user wants to access multiple buckets. And also, if we want to provide only temporary access to any bucket, then we can do so by just using assume role, because the credentials will automatically expire after a certain duration. The next API is assume role with web identity, which mainly provides web identity federation. Users in an external application can access S3 resources in RGW without even owning any kind of permanent credentials. The only requirement here is that the users need to authenticate themselves with an OpenID Connect compliant provider. And currently in RGW has been integrated with Keycloak, and we has been integrated with Keycloak. So this is the flow of assume role with web identity. The user in an external app authenticates itself with Keycloak. It gets back a web token, which can either be an access token or an ID token. And then the user can invoke assume role with web identity using that ID token or access token and get back temporary credentials. And then later it can use those temporary credentials to make S3 calls to RGW. So there's another kind of IAM policy which come into play here. They are known as session policies. So session policies can be passed as input to the assume role APIs. So if we go by the principle of least privileges, then we need to define a permission policy for a role which allows the least permission to its users that want to assume it. But sometimes we may define a policy which is generic for all the entities that assume a role. So session policies can be used to restrict those permissions further. And the final permission is an intersection of the IAM permission policy attached to the role and the session policy. So let me give you an example here. This is the first one is a permission policy attached to a role, which allows all S3 actions on my bucket. But if you want to restrict a user assuming a role to just a read-only mode, then we can define the actions to list, bucket, and get object. And the resultant permission will only allow these two S3 actions in the assume role APIs. So how can roles be defined in a bucket policy? So let's say we want to provide access to all users that are assuming a role to a particular bucket. Then in that case, we can specify the roles ARN in the bucket policy. If we want to restrict access only to a particular session of the role to access a bucket, then we can specify the role session name in the bucket policy. And if we want to allow or deny access to any external user to a bucket, then we can specify its user name in the principal element of the bucket policy. And the username can be derived from the subfield of the incoming web token in case of assume role with web identity. So this is a flowchart of how we evaluate permissions in RGW based on different kinds of identity and resource policies. This is based on AWS STS. So the default result is always a deny. We take into consideration all the user policies, the role permission policy, and then also the bucket policies. And if any of the uh, policies return a deny or have a deny for a particular S3 operation, then we return a deny to the end user. If any of the statements have an allow action, then that S3 operation is allowed. If there is neither a deny or an allow, then even in that case, we deny the S3 operation. So now we'll move on to an authorization strategy in STS, which is known as ABAC, and it is based on attributes or tags. So tags are key value pairs. Tags can be multi-valued, and we can attach tags to roles, buckets, or to incoming web tokens. And the tags which are there in the incoming web tokens are known as session tags. So the benefits of using ABAC is that we need to define lesser number of permission sets. We can also define more generic permission sets, and permissions can be automatically granted or revoked just by tagging a principal or a resource appropriately. So I'll walk you through a simple example of how session tags come into play. So this is a web token associated with an external user in case of assume role with web identity. And there's a tag called department which has been set to the value engineering. Now this user wants to access a S3 resource in RGW. It's the role name is S3 access, and its trust policy looks like this, which says that the request tag department value should either be engineering or sales. And since the user has its department tag set to engineering, the external user will be allowed to assume this role. Next, we have the roles permission policy, which says that the resource tag department must match with the principal tag department value. Now, all the tags that are there in the session or in the web token get converted into principal tags in the temporary credentials. So if we have a bucket, my test bucket, and we tag it appropriately, set the tag department to engineering, then this condition also gets satisfied, and the user will be allowed to access that bucket according to the policy that has been defined here. So in this way, we can tag different buckets and different users and then match them according to such a policy, and have those users access the buckets based on a generic permission set like this. So the example that we saw in the previous slide was just about a single valued tag. But let's say if we have a tag which is multi-valued, then we can have more complex permission sets and more complex policies. So there's one such condition element known as for all value, which says that every key value in the request must be a subset of the condition key value. So in this example shown here, it says that the principal tag department must be a subset of the resource tag department. And the resource tag department values have been set to sales, engineering, and marketing. And the incoming principal tag department values have been set to engineering and marketing. Now, since that's a subset of the resource tag values, this condition evaluates to true, and the incoming user will be allowed to access the buckets according to the policy to which this condition has been attached. Next is another condition element which is known as for any value, which says that any key value in the request must match with any key value of the condition. So here if you see the resource tag values are engineering and sales, and the principal key values are marketing and engineering. Now since engineering is common between these two, this condition element evaluates to true, but these values will not evaluate to true for the previous slide for all values, because the principal tag department is not a subset of resource tag department. And there are other condition key elements like string equals, string like, string equals ignore case, string like ignore case, and we can use them in conjunction with for all value and for any value to come up with different kinds of permission sets. We can also have multiple conditions in one policy. All those conditions must evaluate to true for a policy to hold true. And in this way, uh, tag-based permission sets can be very helpful in defining simple and generic IAM policies. So we've also extended STS to something known as STS Lite. This has been built upon an STS API known as Get Session Token and has been mainly done for external authentication like Keystone LDAP authentication. In case of Keystone authentication, every S3 call has to go to an external Keystone IDP. In order to reduce the latency and the load on the Keystone server, we make the get session token authenticate with the Keystone IDP, and then the user gets back temporary credentials. And then the subsequent S3 calls can be made to RGW using these temporary credentials, and the authentication need not go to the external IDPs. So this is a simple flow of how get session token works. The get session token call goes to RGW using EC2 credentials. It further goes to the Keystone IDP, and upon receiving a successful authentication, it gives back temporary creds, and the subsequent S3 calls are made using these temporary credentials. So moving on to CustomCredentials Provider. This is a module in Java which is similar to Web Identity Token Credentials Provider present in AWS SDK Java. But the Web Identity Token Credentials Provider had certain limitations. So it did not have the provision to take in the session duration and session policies as input parameter. And it would only take a web token as a config option and use that web token to refresh the temporary credentials in the background. But once the web token would expire, then there was no way to, keep it getting refreshed in the background. So this provider has been built upon the Web Identity Token Credentials Provider. First, it takes in the session duration and session policies as the input parameter, and it also provides a refresh token as a config option. So using the refresh token in the background, we can get a web token, and once the web token expires, we can keep refreshing the web token and the refresh token. And additionally, it will keep refreshing the temporary credentials also in the background. So this aids in easy integration of any Java applications with RGW STS. So, and now we talk about what has been implemented for STS in multi-site. Currently, we just have the role and policy metadata replication available. If you create a role in the primary zone and attach a policy to it, both the role metadata and the policy metadata will get replicated over to the secondary zone. We still need to work on OpenID Connect Provider metadata replication in RGW. So these are the various references and documentation links for STS and all its associated topics. And there's a link to the CustomCredentials Provider GitHub repo also. And this brings me to the end of my talk. Thank you. If there are any questions.
Hi, is this all available in Reef or Main or the last pull request you were showing?
Yeah, so the multi-site metadata replication is already there in Reef.
In Reef. Okay, yeah. Thank you.
Well, the same question actually.
Okay.
Starting with Reef, that support will be there.
Yes, but all of STS has always been there starting from Nautilus. The multi-site metadata replication is there starting since Reef.
So is the metadata replication working also for non-active configuration? So is there a way to enforce this policy propagation, for example, when you have only few buckets synchronizing?
So roles are outside the bucket realm.
Yeah.
So
Okay.
I'm not sure how that works, but if like what I know as of now is that if you have an active configuration, the role created in a primary zone will replicate over to the secondary zone.
Thank
They
you.
are not associated with buckets.
Okay.
They are a separate metadata on its own.
Okay.
Sorry, can I ask a question?
Sure.
Yep. So you talked about the assume role with web identity, or being compatible with Keycloak, or
Yeah.
working with Keycloak. I'm assuming that was that just what was chosen to develop it with? It should work with other.
Yeah, it should work with other IDPs. Some people in the community have already tried it with other IDPs and they did hit some roadblocks, but those things were ironed out and other integrations have also worked fine.
Cool. That's good to hear. Thank you.
Yeah.
Are there any performance improvements if moving from defining the policy on a bucket for each external user that wants to use it versus using the assume role?
Haven't measured that, so can't really say.
Okay. Cool.
So any more questions? I think it's done. Yeah. Thank you.